Welcome back to Lab to Lecture. Today, we're diving into topic 3. Ready to tackle stoichiometry like a pro? Grab your notes, gear up, and let's crack those calculations wide open. Question 1. Compound X has the following composition by mass. Hydrogen 3.66%, phosphorus 37.80%, oxygen 58.54%. Calculate the empirical formula of compound X. Empirical formula calculations involve 3 steps. The first step is to know the percentage of each element present in the compound. So we have 3 elements, hydrogen, phosphorus, and oxygen. The percentage of hydrogen is 3.66%. Percentage of phosphorus is 37.80%. And the percentage of oxygen is 58.54%. So the first step, change percentage into grams, and that happens simply by replacing the percentage by grams. Simply imagined as if you have a sample of 100 grams. So here we have 3.66 grams, and there you have 37.80 grams, and oxygen is 58.54 grams. Once again, we just imagined the sample to be of 100 grams. So replace percent by grams. So that's the first step. The second step is divide each by its relative atomic mass. So for hydrogen, you divide by the relative atomic mass of hydrogen, which is 1, and for phosphorus, divide by the relative atomic mass of phosphorus. From the periodic table, is found to be 31, and divide the grams of oxygen by 16, because that's the relative atomic mass of oxygen. So for hydrogen, 3.66, phosphorus is going to be 1.22, and oxygen is going to be 3.66. So those are the moles. So the second step, changing grams into moles. Now the last step is to look at the least of these numbers and divide each of these by this number. So here we divide by 1.22 because that's the least of the 3 numbers. And here you divide by 1.22, which is going to be 1. And here once again by 1.22. So now the ratio is going to be for hydrogen 3 per phosphorus, 1 per oxygen 3. So that's the ratio between the 3 elements. So the formula is going to be H3P1O3. Question 2. Dilute sulfuric acid and aqueous potassium hydroxide are used to make aqueous potassium sulfate. The method includes use of the following apparatus. So this is titration. Calculate the number of moles of potassium hydroxide in 25 cubic centimeters of 0.100 mole per decimeter cubed of potassium hydroxide. So here we have the volume of the potassium hydroxide, and there we have the concentration of that potassium hydroxide solution. Remember, we have a triangle for concentration. You may use that triangle. So here we have number of moles and their concentration and volume down below. So now we need to calculate the number of moles, N. So N equals C times V, concentration times volume. And that is equal to concentration is 0.100 times 25 cubic centimeter, but you have to convert it into cubic decimeters. Units have to be matched, cubic decimeters in both of them. So you have to divide by 1,000. Remember that. And that gives us 0.0025 mole of potassium hydroxide. So the answer is 0.0025. B. Deduce the number of moles of sulfuric acid that reacts with potassium hydroxide. Now, according to the balanced chemical equation, the ratio between sulfuric acid and potassium hydroxide is 1:2. So for each 1 mole of sulfuric acid, you need 2 moles of potassium hydroxide. Okay, so always potassium hydroxide is double the amount of sulfuric acid. Okay, so if you have 2 potassium hydroxide, you need just half of it, which is 1. So always you need sulfuric acid to be half of the potassium hydroxide, because the ratio is 1 for sulfuric acid, 2, which is double for the potassium hydroxide. Since here in potassium hydroxide, we have that number of moles, it means we need half of it to be for the sulfuric acid, because once again, remember the ratio is 1 to 2. Okay, so simply you need to take 0.0025 and then divide it by 2 or multiply by half. And that gives us 0.00125 moles of sulfuric acid. So that is the amount of sulfuric acid. So 0.00125 moles of sulfuric acid, H2SO4. Question C. Calculate the volume of sulfuric acid required. Once again, remember the triangle. Here we have the triangle of concentration, NCV. So now we're asking for the volume. So V equals N over C of the sulfuric acid. We know the number of moles of sulfuric acid from that previous step, okay? And we know the concentration, which was given at the top here. Concentration of sulfuric acid, it was given as 0.0625. So we just need to plug in the numbers in that equation. So 0.00125 over 0.0625 concentration of sulfuric acid. So the answer is going to be 0.02 cubic decimeter. But he's asking for cubic centimeter. This is very important point. Look, after reaching all of these steps, and then you forget just to change it from cubic decimeter into cubic centimeter, you may lose the whole mark. That's why you have to pay a close attention to the units. So in order to convert from cubic decimeters into cubic centimeters, you have to multiply by 1,000. So the answer after multiplying by 1,000 is going to be 20 cubic centimeters. So the answer is 20. Question D. He's simply telling you that we are going to keep everything the same, except here the product is going to be potassium hydrogen sulfate, and that makes the ratio between the sulfuric acid and the base 1 to 1. So it's not like the previous ratio, because the product now is different. Look at the previous ratio, it was 1 to 2. So now, since the product has been changed in that question, we're going to change the ratio. So now the amount of potassium hydroxide is going to be exactly the same amount of sulfuric acid. In that kind of questions, guys, remember when we explained topic 3, I gave you the equation for titration. It's like a golden equation. It makes your life much easier. If you have any titration question, you may apply this formula, which is CV over coefficient equals CV over coefficient. One side for the acid and one side for the base. So here you have acid, and there you have for the base. This is a very important and easy way to tackle questions like this. So simply you take the concentration of an acid multiplied by the volume over the coefficient in the balanced chemical equation. In that situation is going to be 1 equals the concentration of the base times its volume over the coefficient. Since coefficients are going to be different here, we're just going to substitute directly into the equation. So the answer is going to be 0.0625. That's concentration of the acid, which was given in the very beginning of that question, times the volume of the acid, which is the question that he's asking for. Here he's asking you to calculate the volume of the acid. So he's asking for VA, volume of the acid, over the coefficient in the balanced chemical equation, which is 1, equals the concentration of the base, once again, which was 0.025. All of these numbers were given in the very beginning of the question, if you get back to the question. And once again, the coefficient here in that new balanced chemical equation is 1. So you do the math, and then you're going to find that the volume is 0. So VA is 0.04 cubic decimeters. But remember, here he's asking for cubic centimeters. Look, after doing all of this, and then you forget to change it from cubic decimeters back into cubic centimeters, you may lose the mark. So you have to pay a close attention to units, especially in these questions. So here you just need to multiply by 1,000, and that gives you 40 cubic centimeters. Question 3. Here we have a chemical reaction between potassium and water, and that gives you potassium hydroxide and hydrogen gas. Remember, in these types of questions, always he's going to hold a relation between any two substances. Maybe the two substances in the reactant side, maybe in the product side, or maybe one in the reactant and one in the product side. So you have to first assign which two substances he's working on. So as you may see here, he's working on the amount of hydrogen gas. So he's looking for hydrogen gas, okay? This is one of the products. And he's giving you information about the potassium. So this is one of the reactants, okay? So we're not interested in potassium hydroxide. We're not interested in the water. We're just interested in a relation between potassium, metal, and hydrogen gas. And then he's going through series of steps. So the first question here, he's asking for number of moles. Remember, always number of moles is when you divide the given mass over the molar mass. So remember, we have a triangle for the number of moles, okay? We have number of moles equals the given mass over the molar mass. So the number of moles of potassium equals the given mass is 2.34 over the molar mass of potassium from the periodic table is going to be 39. And that gives us 0.06 moles of potassium. So the answer is 0.06. Next point, determine the number of moles of hydrogen gas formed. Now he wants number of moles of the gas. According to the balanced chemical equation, the ratio between potassium and hydrogen is 2:1. So for every 2 moles of potassium, 1 mole of hydrogen gas is going to be released. So you may divide by 2 or multiply by a half. So that gives you 0.06 divided by 2 or multiplied by a half, which is known to be the mole ratio. And that gives us 0.03 moles of hydrogen. So the answer is 0.03. Next point, calculate the volume of hydrogen gas. Remember, 1 mole of any gas is 24 cubic decimeters at room temperature and pressure. So we need to take the number of moles and multiply by 24. So 0.03 multiplied by 24, that gives us the volume of that gas. So the answer is going to be 0.72 cubic decimeters of the hydrogen gas. But once again, look at the units. He's not asking for cubic decimeters. He's asking for cubic centimeters. So you have to convert it into cubic centimeters. You have to multiply by 1,000. And if you multiply by 1,000, the answer is going to be 720 cubic centimeters of the hydrogen gas. So the answer is 720 cubic centimeters. Question 4. This is a hydrated salt question. You are going to work it out exactly the same way as if you are working with empirical formula question. But here the ratio is going to be between the salt and the water itself. So it's not going to be like between elements, it's going to be between salt and water. So here the salt is magnesium sulfate, MgSO4, and water. Okay, here he started with giving you the grams of magnesium without water, after removal of water, and he told you that number of grams was 2.40. So we have 2.40 grams of magnesium after we heated it up and we removed water. So we need to convert that grams into moles, and we're going to do that later on. But he just did that step for you for water directly. So he just saved your time, and he gave you the number of moles of water, which was 0.140. It was given here. That's the number of moles of water molecules in the compound. So you need to convert grams of magnesium sulfate into moles, and simply by dividing by the molar mass of magnesium sulfate. That's why here in the first step he is asking you to calculate the relative formula mass of magnesium sulfate. So MR of magnesium sulfate equals the relative atomic mass of magnesium 24 plus the relative atomic mass of sulfur 32 plus the relative atomic mass of oxygen 16, but that is repeated 4 times. And if you add up all the numbers, they're going to give you 120. So that's the relative formula mass, 120. Remember, we never use units for relative formula masses. And the numerical value of the relative formula mass is going to be exactly the same as the molar mass of magnesium sulfate. So divided by 120 to figure out how many moles do we have. And if you do this calculation, it's going to give you 0.02 moles of magnesium sulfate. So now we know the number of moles of magnesium sulfate. When you have number of moles, we divide by the least of them. So since 0.02 is lower than 0.140, so we're going to divide both by 0.02. And that gives us a ratio of 1 to 7. So we have 1 unit of magnesium sulfate per 7 units of water. We just solved the question in one whole process, but he's just cracking this question into steps. So in step B, he's asking you to determine the number of moles of magnesium sulfate. We already did it here, and we found that it's 0.02 mole of magnesium sulfate. And in the next point, he's asking you to determine the value of X. In other words, he wants you to find the formula of that hydrated salt. So as we mentioned before, the ratio is 1 to 7. So it's going to be MgSO4.7 water molecules. It means we have 7 water molecules included in the structure. So X is 7. So the next question is also hydrated salt question, and exactly you're going to follow the exact same process. So I'm going to leave that question for you, and to download the file, just send me an email. I'm going to send you the whole file, so you may practice that question by yourself, and it's exactly the same process that I did before. So I'm going to send you the file. Also, I'm going to send you the mark scheme of it, so you may check your answers. One more question. Here we have a reaction between sodium metal and water to give you sodium hydroxide and hydrogen gas. And he gave you the grams of sodium. So we have a relation between sodium. That's one of the substances we are interested in. The other substance that we are interested in is sodium hydroxide. So we're holding relation mainly between sodium and sodium hydroxide. But once again, you don't have to figure out the whole question in one process. He just dissected the question into points. So let's go with it point by point. So the first point, he's asking you to calculate the number of moles of sodium. Remember, number of moles is always mass over molar mass. So the mass of sodium given to us was 0.345. So we divide the given mass 0.345 over the molar mass of sodium from the periodic table, 23, and that gives us 0.015 moles of sodium. So 0.015 moles of sodium metal. The next point, determine the number of moles of sodium hydroxide formed. As you may see here, the ratio between the two substances, 2 to 2. So for each 2 moles of sodium, 2 moles of sodium hydroxide are going to be formed. So the number of moles of sodium hydroxide is going to be exactly the same as the number of moles of sodium, because the ratio is 2 to 2. So for every 2 moles, 2 moles, 4 moles, 4 moles, any number, the same number. So the answer here is going to be, again, the same. The answer is going to be 0.015 moles of sodium hydroxide. So now we know the moles of sodium hydroxide. The next point, calculate the concentration C of the sodium hydroxide aqueous solution. So remember, once again, we have a triangle, and the triangle says N number of moles in an aqueous solutions, and down below we have C and V. So it's concentration times volume. He's asking for concentration, so C equals N number of moles from the previous step over the volume. And the volume has to be in cubic decimeters. So number of moles from here, 0.015 divided by the volume in cubic decimeters. The volume was given as 50. But one of you may argue that volume for water is not the volume of the aqueous solution of sodium hydroxide. Remember, the volume of water, it represents most of the volume, let's say 99.9% of the whole solution, because exact volume of the solute is negligible in comparison to the volume of the water solvent itself. So you may consider the volume of water to be the volume of the whole solution, because the solute itself, it represents just a tiny portion of that overall volume of water. So you may take volume of water as the volume of the overall solution. So the volume here is 50. When you convert it to cubic decimeters, it's going to be 0.05 cubic decimeters. And that gives us 0.3 moles per cubic decimeters of sodium hydroxide solution. So the answer here is 0.3. Next point, determine the MR of sodium hydroxide and calculate the concentration of sodium hydroxide in grams per decimeter cubed. So first of all, we need to calculate the relative formula mass of sodium hydroxide. So MR of sodium hydroxide equals the relative atomic mass of sodium 23 plus relative atomic mass of oxygen is 16 plus relative atomic mass of hydrogen 1, and all of these numbers add up to 40. Remember, in the relative formula mass, we never have units. Now, to calculate the concentration of sodium hydroxide, now we have already the concentration of sodium hydroxide in mole per decimeter cubed. To convert from molar concentration into mass concentration, you have to multiply by the relative formula mass. So simply you take the molar concentration, 0.3, that's said to be molar concentration. Molar concentration means the unit of it is mole per decimeter cubed. And to convert it into grams per decimeter cubed, you have to multiply by the relative formula mass, which is 40, and that gives us 12 grams per decimeter cubed. So the answer is 12. Next question. Esters are part of the organic chemistry, topic 11, and we haven't reviewed topic 11 yet. But when we come to it, you'll know that this ester could be named as methyl methanoate. Next, deduce the empirical formula of ester. So first you have to count every single atom in that formula, in that displayed formula, and then you have to find the simplest whole number ratio between them. So we have 2 carbon atoms, so it's C2, and we have 4 hydrogen atoms, H4, and we have 2 oxygen atoms, O2. If you find the least common factor between them, which is 2, and you divide each by this number, the simplest ratio is going to be C1H2O1. That one is the empirical formula, which is the simplest whole number ratio. Next, Buckminster fullerenes is a simple molecular form of carbon. The MR of this simple molecule is 720, and he wants to know how many particles. You have to take MR, that relative molecular mass, 720, and divide it by the the relative atomic mass of carbon, which is 12, and that gives you 60. So we have 60 atoms of carbon in each molecule of that Buckminster fullerene. So 60 carbon atoms. Next, gallium is in the same group of aluminium and forms similar compounds. Predict the formulae of gallium-3 chloride. Remember the crisscross method or crossover method, you may name it. So here we have gallium, and it has a charge of 3 positive. Remember, all metals have positive charge, they are cations. And chlorine, when it forms an ion, it becomes chloride. It has 1 minus charge, and then you crisscross the numbers, so it gives us gallium 1, chloride 3. Gallium 3 sulfate. Once again, we have gallium 3 plus, and sulfate is a compound ion. Its formula is SO4, and it carries a charge of 2 minus. So you cross the numbers without charges down below, and it gives us gallium 2 SO4 between brackets because it's a compound ion, and then you put down below 3. So that's the formula of gallium 3 sulfate. Next, compound Y has the empirical formula H3PO4 and a relative molecular mass of 98. Deduce the molecular formula. So this is a kind of molecular formula question given the empirical formula. So you're given the empirical formula and we need the molecular. Remember, empirical is the simplest whole number ratio, while molecular is the actual. So we need the actual. We need to know how many times this simplest formula has been simplified. To do so, you have to calculate the mass of the empirical formula. So the first step, you need to know the mass of that simplified form. So the first step is to know the empirical formula mass, and that is 3 hydrogens and 1 phosphorus. Phosphorus is 31, and 4 oxygens. Oxygen is 16. They add up to, so we've found that the simplified mass is 98 and the actual mass is 90, because he told us that the molecular mass or relative molecular mass is 98. So the actual is exactly the simplified. So once again, the molecular formula is H3PO4. In other words, it hasn't been simplified because it was already in the simplified form. The names of the elements of period 2 of the periodic table are shown: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Identify the element which forms a basic oxide with the formula X2O. I'm not going to get into the idea of basic oxide now, but the formula was given as X2O. Let me just make it clear for you. So here we have X2O. If you work it out backwards, before you crisscross the numbers were like this. The 2 was here as a power of oxygen, and the 1 was here as a power of X. It means X has a charge of 1 positive, and oxygen has a charge of 2 negative. That before you crisscross and you make the formula. It means you need an element that can form a cation with 1 positive charge, and that happens only in group 1. So the element has to be in group 1. Among all of these elements, the only element in group 1 is lithium. So the answer is lithium. Ester Y has the following composition by mass. That's pretty much the same question as we answered before. I think it was question number 1. It was actually the first question that we answered here in this video. So I'll leave that question for you. Practice it and you can check your answer in the mark scheme. Now let's practice question 13. The formula for crystals of hydrated copper 2 sulfate is CuSO4.5 water molecule. So that's the formula of the hydrated salt. And here we have series of steps that tells you how we formed that hydrated salt, but I'm not going to get into these steps now. I'm just going to get directly into the question. The question is calculate the number of moles. So once again, he needs a number of moles of the acid H2SO4. And you have a volume of that acid. Pay attention, the volume was given in cubic centimeters. You have to convert it into cubic decimeters. And you have the concentration of that acid solution. So you have C and you have V. Remember, in the triangle, we have number of moles N equals C times V. So you have the concentration 0.200, that's concentration of the acid solution, times volume 50.0 divided by 1,000 in order to convert it into cubic decimeters. And that gives us 0.010 mole of the sulfuric acid H2SO4. So the answer is 0.010. Next, deduce the number of moles of copper sulfate hydrated salt that can form. Now, once again, if he's asking for a number of moles, you have to check the ratio in the balanced chemical equation. And the ratio here, as you may see here, 1 mole of sulfuric acid forms 1 mole of that whole hydrated salt. Okay, so the ratio is 1 to 1. It means it's exactly the same number of moles of sulfuric acid. So if you got 1, it's going to be 1. If you got 2, 2, 3, 3, whatsoever you have in the sulfuric acid is going to be exactly the same in hydrated copper sulfate. And you deal with the hydrated copper sulfate as if it's a whole molecule. Okay, so the number of moles of hydrated copper sulfate, once again, is going to be 0.010. How did I know that? From the ratio between the substances in the balanced chemical equation. Next, the MR of hydrated copper sulfate is 250. So he saved our time by giving us directly the relative formula mass of hydrated copper sulfate. Calculate the maximum mass of hydrated copper sulfate that can form. Remember, once again, M over M. Small m is the given mass, which is actually what he's asking for, and big M is the molar mass or relative molecular mass, and N is the number of moles which we have found in the previous step. So M equals N times M, or MR, and N was given as 0.010, MR was given as 250, and that gives us a mass of 2.5 grams of that hydrated salt. So the answer is 2.5 grams. Next, we have here an equation, and he's asking for balancing the equation. Now, balancing is a topic that may practice in grade 7 or 8, and there is no fixed procedure or way to tackle this balancing question. But from my experience, I may give you precious advice. If you have an equation and you need to balance, you can tackle any balancing question by leaving hydrogen and oxygen, because they are very common in questions and in equations. So if you leave them, the last atoms to be balanced, and just look at atoms that are found once in each side of the equation, in the reactant side and in the product side. So now I'm going to ignore hydrogen and oxygen for time being, and I'm going to focus on atoms that appear once in each side of the equation. So I'm going to start with nitrogen. Firstly, I may notice that nitrogen is balanced, but now if you look at atoms like chlorine, Cl, chlorine is found once here in the whole reactant side, and it's found twice in the product side. So you need to multiply this formula by 2 in order to make chlorine 2. Next, let's look at nitrogen. Now nitrogen in that left side, it became 2, okay? So you need to put here also 2, because now nitrogen will be like balanced in both sides. So I balanced chlorine, I balanced nitrogen. Let's look at other atoms. Let's look at calcium. Calcium is already balanced. Now, when you are done with all atoms, now you may look at oxygen or hydrogen. So if you count here hydrogen atoms in the whole reactant side, we have 4 atoms of hydrogen multiplied by 2. It means we have 8 hydrogen atoms, and there you have 2 hydrogen atoms. Overall, we have 10 hydrogen atoms. Here we have 3 times 2, 6 hydrogen atoms. We still need 4 hydrogen atoms. That's why we multiply this water by 2. So now we have overall 10 hydrogen atoms. Now the equation is balanced. Next, ester Z has the empirical formula C3H6O and a relative molecular mass of 116. This is exactly the same question as we did before. I'll leave it for you, but once again, let me guide you. You need to calculate the mass of the empirical formula and you compare it with the actual formula so you know how many times you need to multiply the empirical or simplified formula. I'll leave it for you and you can check your answer from the mark scheme. So let me pick one last question before I end today's lecture. Okay, let me pick this question. So question 20, fluorine reacts with sulfur to form a compound which has 25.2% sulfur by mass and a relative molecular mass of 254. Determine the molecular formula of this compound. For questions asking to determine molecular formula, you have to be given the empirical formula and you have to be given the relative molecular mass. Actually, you had already the relative molecular mass. It was given to you as 254, but you still need the empirical formula. He didn't give it to you directly. That's why this question is 3 marks. So firstly, you have to figure out the empirical formula. Remember, to find the empirical formula, you have to go through the steps from percent into grams and then into moles by dividing by the relative atomic mass, and then convert these moles into simplest ratio. So let's start with sulfur here and fluorine there. Now, the percentage of sulfur is 25.2%. Now, the percentage of fluorine, it was not given directly, but you can just figure it out because, you know, all of them, they should add up to 100 because you have a compound that's formed of fluorine and sulfur and nothing else. It means if sulfur is 25.2%, the remaining of the 100 is for fluorine, which is 74.8%. Now you convert that percent into grams simply by placing the percentage sign by gram. So it will be 25.2 grams. That happens if you have a sample of 100 grams. And here is 74.8 grams. And then divide by the relative atomic mass of each of the elements. So if you divide for sulfur, you have to divide by 32. And for fluorine, from the periodic table, you have to divide by 19. And that gives us 0.788 for sulfur and 3.94 for the fluorine. Now, the list of these numbers is 0.788, so we divide both by this number, so 0.788, and here 0.788, and that gives you the ratio of 1 for sulfur, and for fluorine is going to be, so the empirical formula is S1F5. That's the empirical formula. Now we know the empirical formula. You have to find the mass of this empirical formula. The mass of the empirical formula is sulfur is 32 and fluorine is 19, but you have 5 of it, so you have 5 times 19, and that gives you a mass of 127. That's the mass of the empirical formula. So you divide the actual formula, which is 254, over the empirical formula mass, which is 127, and that gives you 2. It means it has been simplified 2 times. In order to revert it back into the original actual formula, you have to multiply it by 2. Every subscript has to be multiplied by 2. So for sulfur, instead of being S1, it was going to be S2, and then fluorine F10. Now, that is the molecular. Remember, molecular means actual before simplification. So S2F10, that's the actual, and it has been simplified 2 times. So that's it for today. These were some of the trickiest questions in the exam. I hope that helps. You need to practice the rest of the file. I'm going to send it to you. And you have the mark scheme. You have to solve plenty of questions and check your answers. And if you have any question, just leave it in the comment section below. See you next time.